Yeah, I'm Patrick Mann. I'm the manager for technical operations for WestGrid. So welcome to the first of this term's talks. I'm going to just give an introduction to WestGrid, pretty short and sweet, and essentially open things up for questions. I think that at most sites there's a WestGrid representative who can ask questions, who can answer questions later on if you want, or feel free to ask them during the talk. Somebody here can tell me if there's a question on the machine, and I can try my best to answer them. So I say we're going to try to keep this one pretty short and sweet. It's really just a quick introduction to what WestGrid has got, a little bit more about Compute Canada and what the organization is, and then and nothing special. I'm not going to try to do any demonstrations or whatever. So we'll just go through it as quickly as possible, and then open up for questions. So an introduction. I'm the manager, and this is the first of our seminar series. Now, if I can only make things. So WestGrid itself, what is it? Well, we're one of 4 regional high-performance computing consortia that make up Compute Canada. WestGrid is from Manitoba to British Columbia. In Ontario, there is Compute Ontario, which is composed of itself 3 separate smaller organizations: Calcul Quebec in Quebec, and AceNet in the Atlantic provinces. So these 4 together form Compute Canada, and it's very much a Canadian federal model with the provinces sort of getting together and working with the federation itself. And generally, what happens is that Compute Canada works with the government and works with our funding agencies, and then distributes the funds out to each of the regions who actually purchase and run the equipment and supply the support and system administration, those kinds of things. So WestGrid itself, we've got those 4 provinces, and we've got 15 partner institutions. You can see the list there. Pretty much all the major universities in Western Canada. So we probably worthwhile noting for those who are new. Of course, we are academically focused. We're a research organization providing high-performance computing resources to researchers in Western Canada. Compute Canada itself, I don't know how many of you are familiar with Compute Canada. It's been around for a few years, but has recently started to really to become this sort of national organization, and just recently has hired a whole bunch of new staff. In particular, Mark Dietrich, the President and Chief Executive Officer, only became the President back in April of this year. Dugan O'Neill, Chief Scientific Officer, he's a physicist, and has joined. He joined back about the same time. No, he joined about a year ago, and then most of the senior management has joined just in the last few months. The rest of them there, the CFO, communications, and then some technical staff. A reason for this big change with the new staff was the strategic plan, which was developed over the last few years. Over the last year or so, there was quite a big effort to consult with all our members, with all the universities, all the institutions, and also with our users to come up with a bit of a plan, some idea of where we're going to go. Did I see somebody just inside outside our door? Sorry, just somebody looked like they might be coming in here. Yeah, and that strategic plan talked about governance and such, and that's why we developed the strategic plan and put Compute Canada a bit more on the map than I think it has been before. A new planning exercise has started in Compute Canada just since I think the beginning of the summer. It's called Sustainable Planning for Advanced Research Computing, or SPARC, and all of us who are a bit older, of course, get those mixed up with the old SPARC processors, but this one's different. The question Compute Canada was asking was what kinds of digital infrastructure investments are required to enable Canada's excellence and leadership in science and innovation, and of course, in particular, with the focus on what we've termed advanced research computing. That's ARC, rather than the older word high-performance computing, because high-performance computing focused quite a lot on things like large supercomputer clusters, and nowadays we've branched out into clouds and portals and such. So for the purposes of funding requests and such, we call it ARC, A-R-C. So this SPARC plan, there's the advanced research computing part of that, has been over the summer meeting with some of the expert bodies. And expert here means things like CFI and Canary, the guys with the big funds, Industry Canada, but also with all our constituents, in particular the principal investigators, the PIs for the projects that are using WestGrid, and of course the institutions. And starting to gather information for long-range plans for the next few years, up to maybe 2017 or 2018 or so, somewhere in there. We also issued a call for white papers, and that was targeted at what we might term communities of interest. Things like the astronomers, the CANFAR guys have submitted a white paper and such. Some of the chemists have, and telling us a little bit about where they think their subjects are going, and what they might need in the next few years in the way of computing resources. I should note at this point that this is getting driven in the sort of technical direct sense by the fact that most of our machines are getting old. That's across Canada. I think the last real serious funding round was 2010, so that's 4 years ago now, and some of our machines are much older than that. So it's getting to the point where we really do need a refresh, and we're going back to CFI to ask for a new program, new funding round. And that is actually happening. CFI have, at least informally, been in discussions with Compute Canada executives and discussing what kind of plan they would have for a refresh over the next year. So a lot of this is focused very much on looking at that kind of new funding. If you're interested in any of that kind of thing, please get in touch with us, and we're still open to things like white papers, if there are particular subjects or areas that would like to talk to us about what their computing needs might be in the future. Okay, so now I'll just work through a few of the more things that Compute Canada and in a few minutes WestGrid actually provides. One of the things I think I'll just mention on the Compute Canada end right away is the High Performance Computing Symposium, just what we call HPCS. Happens once a year. It's the big conference that brings together our users, our staff, researchers and such to tell us what's going on in high-performance computing in Canada. HPCS 2014 was back in June. That was in Halifax, run by AceNet. Next year, it'll also probably be somewhere in June, and that will be hosted by Calco Quebec. And the year after that, in 2016, WestGrid will be hosting it. So you can see how it goes. Each region sort of hosts the HPCS in a round robin. I would really recommend going to HPCS. It's a great way to figure out what's happening in Canada in the way of both research and the plans of Compute Canada. There are usually big consultations with users and specific meetings, as well as research summaries and talks and that kind of thing. So these are well worthwhile attending if you can do it. It really gets you into the HPC community in Canada. Compute Canada has compute sites with hardware spread throughout Canada at many institutions. The latest one is the BC Cancer Agency, in fact, with the Genome Sciences Centre. That one's, of course, focused on the bioinformatics end of things. And I should just note that it is enabled through funding from CFI itself, but also provincially, in this case by the BC KDF, the British Columbia Knowledge Development Fund. And indeed, if you know of all these things, CFI provides matching funds, and the provinces usually match what CFI provides. So there's sitting right there that whole federal model working with us. So we have funding from a number of different places. Another thing I'll mention here is the annual resource allocation competition. I've got another slide later on because this is kind of critical stuff, but I'll mention it right away. Of course, we have limited resources, and it probably won't surprise everyone to know that we're oversubscribed. So when you're submitting jobs, the jobs wait in the queue until there's enough space on whatever resource, whatever machine you're trying to run your job on, and then the scheduler takes the job and tries to run it. That turns out to be, at least from our systems admin point of view, the biggest, most complicated job I think that anyone's got in all of Compute Canada, is how to efficiently run a huge number of different jobs with different characteristics and such. So the way we handle this is to have a competitive resource allocation competition process where every year you apply for resources. What usually happens is that a PI, a supervisor, applies, and then his team gets to work with his allocation or her allocation, as the case may be. The 2015 competitions were announced this week. The deadline is usually, I can't remember, it's early October anyhow. It's quite a process. We do have to work hard. We do a complete scientific review as well as a technical review of any applications and come up with some allocation of time and storage on our big machines. The slide just notes that we do things like a fast track application where those who have had big allocations in the past can essentially just keep it going. That's by invitation only, however. And we do have a new one this year called Research Platforms and Portals. And I think you can see that that means that we're trying to respond to new uses for advanced research computing, for ARC, things like clouds and portals, where you want something that maybe sits there, front ends, databases, some digital humanities kinds of things. And in that case, you may want not the standard just submit a job and get the results back, but a web portal of some sort, and that needs to exist for more than just a year. So we have this new, say, just announced this year competition. And I'll go through a little later, give you some websites and things where you can start to go on that. Oops, just a minute. So a few just interesting little tidbits of information. So at WestGrid, we've got HQP. That stands for highly qualified people or highly qualified personnel. You may know this from the granting agency end of things. We're always interested in Canada and how many grad students, undergraduates, and highly trained people that we've produced. And when we say HQP here, we mean essentially staff. WestGrid's got 40. Most of them are system administrators and support analysts. Compute Canada, 153. These numbers are not too accurate since it kind of depends on how you count them. You can see the number of users we've got. Number of cores, that's 43,000 cores sitting in WestGrid machines. Storage, 9 petabytes at WestGrid, and operations around about 6 million a year. We get quite a few new users every month. Fortunately, not all those users are active all the time. Otherwise, I think there's no way we could really handle the number of jobs we would have to run. But they balance out in the end. Now back to WestGrid itself. There are our internal staff or central staff. Lindsay Sill is the executive director, and Rob Simmons is the CTO, and I'm the technical operations manager. And then we have finance and administration. I think Todd is probably listening in right now. Todd Zimmerman, he's the collaboration coordinator and is operating or managing these kinds of seminars and webinars and such. And then we have some technical staff and some project coordinators. And I've noted in red that the really important parts I haven't written down for important folks, and those are what we call our site leads at every site, our system administrators, and the analysts. And the analysts are the ones who really work with you, the users, to optimize, to run your codes, to do everything there. System administrators, of course, we need them to run the things, and then site leads just to keep track of everything at every site. Yeah, it's probably worthwhile just noting a few of the projects that are currently using Compute Canada resources. There's one from Dalhousie, satellite observations of the atmosphere, genomics and genetic stuff, biomolecular subjects, and then one interesting one at the bottom, the Ukrainian Cultural Heritage Repository, so more in the digital humanities. Those ones focus on some of the sort of maybe slightly out of the way things. Of course, our biggest users are the chemists. The chemists run Gaussian and NAMD and all the molecular modeling codes, and they run them all the time. I think second biggest are the physicists, things like the computational fluid dynamics, atomic structure calculations, astronomers working on stellar simulations, a lot of those kinds of things too. So it really covers the whole gamut. And one of the things I'd point out right away is that we don't charge for use in any of these machines. You tell us that the science is good and we give you some allocation. But we have a whole ton of different machines throughout Compute Canada and even in WestGrid with very different characteristics. In fact, probably the standard question that we get to support is, which machine should I use? That's because of this very wide range of subject areas and codes and different approaches. In many cases, we can pick and choose a little bit and figure out where your code should go or where your application should go, which machines are the best for them, and then help you to optimize them and get them to run well on WestGrid resources. So some idea of where it's going. I'll go through some of the facilities that we've got. I'm not going to give any details here. So the next talk, which is I think using WestGrid, we'll talk a bit more about what kind of clusters we've got, what are the characteristics, all those kinds of things. I should note that I'll just work through this stuff very quickly. So we have clusters. So I think you probably all know a cluster is a machine which is composed of lots of nodes, each of which looks like essentially a PC. And the nodes are all connected with some very, very fast interconnect. And a lot of the details of which machine is the best says how big are the nodes, how much memory are on them, how many cores on each node, how fast are the interconnects. Are you going to use a job that runs across many nodes and needs to interchange data back and forth? Can it run on one node? All sorts of stuff. And of course, we have some storage sites, which I'll talk about briefly too. Here, the details are on the web. There's the website, www.westgrid.ca, and I'll encourage everyone to have a quick look at that to see. I'll go over some of our WestGrid machines in a second. Of course, basic question is, so can you get an account? In fact, what we do with this resource allocation stuff is we usually put aside about 20% of the total resources, number of cores, amount of memory and such, for anybody who wants an account. So if you're a big user and you got your supervisor who's got a resource allocation, great, and they do their resource allocation competition every year, that gives you big resources. If you just want to log on and you want to start running jobs and seeing how you get things going, then we got this 20% for everybody else. So anybody can get an account, and once you got an account, you can log on to our machines and you can start playing with essentially any of them. Some are specialized machines and require some special access permission, but the other ones, try them out, work on them, see how they go, ask our support guys. So how do you get an account? There are 2 steps. This always gets a little annoying. You have to get a Compute Canada account first, and then you have to get a WestGrid account. If you want to, you can also get a AceNet account and a Calcul Quebec account and go and use some of their other machines as well. I think one of the projects in Compute Canada's bucket list at the moment is to have a single sign-on for across Canada, but I'm afraid at the moment we don't. Each consortium has its own sign-on system. Fortunately, in WestGrid, once you get a WestGrid account, you can sign on to any of our machines. So the first thing, step one, is getting a Compute Canada database. There's where you go. I think it's pretty straightforward. Once you get there, you fill in the form, and usually a couple of days later, you'll get the approval. We do have a little approval process just to make sure that you really are from a Canadian institution and are in that institution. It says PIs must be a faculty, and that's true, but you can also be a grad student. That all works fine, or a research associate. You're given a CCRI, Compute Canada, role identifier, and once you've got that, you're off and running. You can log in to the Compute Canada website. We call this the Compute Canada database, CCDB. In fact, once you get onto CCDB, you can start looking at how much time you used, how much space you used, all that kind of stuff. So you can see how your usage goes. So I won't get any details. Just go to the website, have a go at that. Step two is getting a WestGrid account. Well, the instructions are there. Again, you log on to CCDB once you got that CCDB account. And then within CCDB, you say, I want a consortium account, and in particular, I want a WestGrid account, and off you go. So pretty straightforward at that point. Yeah, I'm not quite sure if I really need to talk about passwords and security, but just quickly, almost all our machines use SSH to access them, so it's pretty basic level of security. We generally don't like you to share accounts. There are ways of sharing data, and again, the right thing to do is to go and ask some of our analysts for help on exactly what you want to do. Everybody seems to be sharing stuff in various different ways, and we do have a number of sharing capabilities, including sort of a Dropbox-like capability. So there's lots of stuff there, and a lot of the details are up on the website. There are policies and such sitting on the accounts page there. So as usual, it's a good idea to have a quick look at the policies and see what we do about data and sharing data and data security. Accounts at westgrid.ca if you want help with setting up your account, or if you got problems or your special case. So feel free to send mail there. Usual things of watching your spam folder. And that first one, if you can do it, use an institutional email address. It's nice to have something that says at ucalgary.ca, because then it's clear that you are a member of the University of Calgary. If you give us your favorite Hotmail account or Gmail account, then we have to ask you where you are and why you're not using a university account. Getting started, we have what are called quick starts. They're pretty big, and they've got everything you need. There's quite a ton of them. The basic one is the quick start for new users. That one, essentially, you got to read. Have a look at it. It'll tell you things about what systems we've got, how you get on them, how you set up your machine to get on them, all that kind of thing. And just note there that the introduction to using WestGrid is in a few weeks' time, and that one also leads you through some of the details of logging in, getting onto the machines, setting up your machine, etc. So very quickly, I'll go through the computational resources and very broadly grouped here. None of the details. So the details are on the website, and you can have a look at those. And again, if you really want to know which machines you should be using, it's really good idea to call up our analysts. So large memory, we got some big memory machines, Hungabee, Breezy, and Grex. Hungabee is a pretty weird one. It looks like a single huge shared memory system with 16 terabytes of memory. That's by special request only. Similarly for Breezy, and Grex is our machine at Manitoba. It's got pretty fat nodes, 48 gigabytes per node. That particular machine is actually focused mostly on the chemists, so it runs Gaussian and has some special capabilities when it comes to running Gaussian. And we have a couple of machines with very large numbers of processors, Orsinus and Parallel. Parallel at University of Calgary, Orsinus at UBC, and you can see quite a number of cores. Parallel also has GPUs attached to it, so if you've got codes that will use the accelerators, the graphics processing units, then, or some visualization capabilities, then you can use Parallel. And then we have machines that are more designed for serial or smaller jobs. Bugaboo at SFU, Jasper at University of Alberta, and Hermes at UVic. So you can see we got pretty broad range of machines here. Also, we have some storage systems. Silo is our big central, more archival system in Saskatchewan. It's not attached to anything. You can move data there, store it. It's mostly backed up, and it's a good place to offload a lot of the stuff that you'd like to keep, but aren't going to use right away. And then both Bugaboo and the Nestor or Hermes cluster, that's all one cluster right now, both have very large attached storage if you need something huge attached to your runs. A little bit more about these resource allocation competition. So we've got that default level. Remember I said there's 20% set aside. That's the default allocation. You get the default. If you want more than that, then off you go. And we've got the research platforms and portals competition. There's the URL for this year's competition, which was announced, I think, only yesterday. So now's the time to start thinking about making a proposal. Again, let me note that it's really good to go and work with your local analyst if you're thinking of doing a proposal. That really, really helps, because they can tell you the kind of things we're looking for and set it up so that we know really what kind of resources you're trying to use or you need. I'm in the end the one in charge of the actual technical reviews. We do have a complete scientific committee which works through the science reviews. On the technical end, we're looking for justifications of the fact that what you think your codes are doing and what you think you might need next year is really what you need next year. And I should say, in the end, on these resource competitions, we usually end up with this much, when we've only got this many resources. So right at the end, there's usually some kind of prorating of the whole thing done at the highest level, okayed by the board and such. So we do our best to make sure that everybody gets what they need and that the allocations are allocated fairly. Okay, so I mentioned getting help all the time. Well, there is the WestGrid site, www.westgrid.ca. I think it's reasonably straightforward. Go and have a go. That number 1 up there is the key thing. Each of those are drop-down menus, and support and resources have lists of the machines, quick starts for every machine, lists of all our software, introductions to the software, introductions to using the systems, all those kinds of things. Down number 2 there, there's also a live status, so you can see if our machines are up and running. Always a good idea to have a look at things, especially if you're having trouble logging on. RSS and Twitter feeds will give you those status updates. Frequently asked questions, those kinds of things are sitting around as well. So there's lots of stuff on the website. The key thing up there then is that one in blue, the support@westgrid.ca. That's the support list. Got problems, mail it to that list. That's the right way to do it. And that goes to all our support analysts, and you'll usually get an expert response, give or take a few hours. Thought I'd mention that we are introducing a new support system in partnership with UBC's IT department, probably later this month. That'll give us a nice ticketing system, and you'll get all those nice ticketing things as well. But you'll still get the expert response from our analysts. So we do also have training seminars of various kinds and research seminars, presentations, mostly through this kind of media at WestGrid through our through the video conferencing. So September, actually, that one just this morning, I heard that we're going to have to delay that probably until the 25th. So the Alinea tools, that's the Alinea DDT debugging system, really powerful for doing parallel debugging, and they were going to come and give us a webinar on how you start to debug big parallel systems, MPI and such. So I'm pretty sure that's going to be the 25th now. Make sure you check the webpage for the details. October 8th is the introduction to using WestGrid, so that's the login and such. And then there'll be a series of other training seminars. We've got some visualization seminars. Everybody's always interested in visualization. And we have a visualization expert on the staff who will be giving these ones actually in person, University of Victoria, Lethbridge, and UBC. But some of them will also be video conferenced out. There's the website. Other workshop, we got small and big data workshop series. So some stuff about parallel processing. I think actually tomorrow there's a big scheduling there's a scheduling workshop. Although I think it's a bit too late to register for that one right now. And then also what we call the Coast to Coast seminar series, and those ones try to highlight some of the researchers and what they're doing. We asked the researchers to give us a talk about their research, but with a focus on how they're using high-performance computing resources. So there's the September 30th one from the University of Texas at Austin. And that's fundamentally about what I'm going to finish up there. There are the two email lists, accounts at westgrid.ca for account problems and support at westgrid.ca for everything else. You should definitely go to www.westgrid.ca to get all the instructions about working with WestGrid resources and such. And Compute Canada has its own website where you can get some instructions about actually getting all those accounts and things. Yeah, that's about it from me. So I'm open to questions, and I think you'll find locally, maybe the local people from WestGrid, the local WestGrid analysts could just hold up their hands so you can see that they're who's there. Yeah, otherwise I'm open to questions.
Can you comment on a little bit of who should investigate WestGrid further? Like a graduate student seeing this talk, they might not know yet whether it's appropriate for them or not.
Gotcha, yeah. So Doug here, he's one of our senior analysts at University of Calgary. I'm at Calgary. Has noted that I may have missed talking a bit about who's really interested in WestGrid and who should be using WestGrid, especially things like folks like new grad students and such. So sure, if you've got in your graduate program, you know you're going to be using off-the-shelf applications, some of the chemistry modeling applications, for instance, or maybe your graduate program assumes that you're going to start working on an in-house code. You're going to develop components for it or modules for it, or maybe if you're really in the field, you'll be developing your own codes. So any of these kinds of things can usefully use WestGrid and Compute Canada resources. Of course, maybe you can run on your own laptop, or you can start developing on your own laptop and then start to move them onto WestGrid. But you start needing to know how you can use big machines. You probably already know that it's not going to fit on your own laptop and you need something bigger. So that's the place. As long as you're at a Canadian university, Canadian institution, you can get an account. And in many cases, the right way to do this is to get the account, dive in, start logging on, and start using one or two of our machines. Talk to your local support people, and develop some experience. Doug, is there anything you think I should mention?
Yeah, we could do a little more there in terms of one of the advantages of these clusters is you can run multiple copies of your program at the same time.
Yeah.
So generally speaking, things that go beyond your desktop, you mentioned not fitting, but something can not fit in a number of different ways in terms of memory or storage, or just being able to do multiple runs at the same time would be the big things there. One other big point about that is that all of these systems are based on a Linux operating system, and so if you have a proprietary Windows-based program, for example, then we would have to discuss with you how that work might be ported in some way to the WestGrid machines.
Did everybody hear that?
No, not well, Patrick. Could you paraphrase it for us, please?
Yeah. The last point was the one that's on my mind right now, was that, of course, lots of people used to using Windows on their laptops and such. All our systems are Linux-based, so you may have applications that are Windows-specific. Go and ask one of the analysts if you do. And Doug pointed out that when I said it doesn't fit on your laptop or desktop or whatever, there's a very broad range under that doesn't fit. Maybe your laptop doesn't have enough memory for whatever system you're using. That happens very commonly in some of these big grid-based, fluid dynamics codes or whatever, where you're using very large grids and they're just not going to fit. Equally, it may be more on the computationally bound end of things, where you run your code and it runs on your laptop, but it's going to take the next 5 years to run. So you want to know how to make it run a lot faster. So I think Doug's point really was that there's a very broad range there. I didn't cover any of those details, and all those details are important in trying to figure out if you're going to use one of our machines and which machine you're going to start using. So that was a quick paraphrase, Doug. But, and that kind of discussion, I think, will happen at that intro to using WestGrid. Yes?
A related question to that, what's sort of the cutoff between like a small job and a big job?
The question was, what's the cutoff between a small job and a big job? The scheduling systems for each of our machines is different, and may preferentially schedule jobs that, for instance, use whole nodes or are multiprocessor jobs using many cores. So the answer is not straightforward, but certainly if it's going to take a few hours, then probably we would call it short job, and might be able to, the schedulers might be able to grab it and schedule it in reasonably efficiently wherever there's a little hole and there's a little bit of resources available. If we're talking about a few days, which is a long job, then the schedulers start having more trouble trying to find the resources they need for those days, for a few days of the job. So kind of in there. If you really want to run for a month or so, then we got to do something really special for you.
Are we supposed to estimate ourselves how long you think it'll take?
Yeah, more or less. But you can work with our researcher, with our support analyst. The question was, do you estimate yourself how long your jobs are, or I guess more generally, what kind of resources your jobs need? That's one of the reasons for diving in and starting to use that that default allocation. Yeah, you got to run some test jobs. You got to run some pilots. You got to see how your job works on a supercomputer, what you can do to optimize it. So there's actually usually quite a bit of work to figure out how you're going to get the best performance and which machines are the right ones. And once you've got that right, then you can start running the big jobs. So, get in there and start working on it. But after a while, yeah, you should know more or less how long your jobs are going to take, how many resources they want, and you have to describe that to the scheduling system.
So if you give an estimate on how many hours it would take on a single core, well, is that kind of helpful information for scheduling things? Yeah,
the question was a detailed question. If you know how many hours your job runs on a single core, does that help with the scheduling? Yeah, it does. But of course, you may be much more interested in how it runs on 16 cores. And that then starts depending on how well your job will parallelize, how many threads you can run, all those kinds of things, right? You may know some of those details.
Yeah, well, I also just do one parallel now.
Yeah.
Yeah.
Gotcha. Yeah, sure. So that works really well. Yes. So you can run it on one core or many cores. Yeah. In fact, Doug had mentioned that before. That another kind of job is one where you're doing some kind of parameter space exploration. In this case, it's a Monte Carlo kind of simulations, where you're actually going to run hundreds or thousands or more jobs all at once. You just want to run a whole bunch of separate jobs. Yeah, we can do that kind of thing too. Some of our machines are good at just giving you a core per job or maybe a node per job or something, and you just go and run a whole bunch of jobs as quick as they can. So I'd really recommend you talk to Doug after the seminar. He can set you on the right track. Questions
can you hear
from
me?
Outside? Yeah.
I'd like to make a comment. I'd like to make a comment about how to find out how to get your memory. In their scheduling talk tomorrow at 1, that's actually the first thing we're going to do, is we're going to explore how to create a proper memory schedule job in terms of memory. So,
just so everybody is the site lead at University of Alberta, and he's giving the workshop tomorrow, so he knows this stuff.
Yeah, it's under events on the WestGrid webpage.
Yep.
And you have to RSVP quickly.
Yeah, I don't know if there's actually room there, but if you can get in, I think this is going to be an excellent presentation. Any other questions? Sounds good. Well, welcome everybody to WestGrid. Hopefully we'll see you logging in and starting to submit jobs in the next 5 minutes or something. But good. Thanks, everyone.